if you try to take the same number of atoms as in my brain, put them in a box and try to construct a brain out of it, that will be the same as my brain. Suppose you know the state of my brain, you want to copy it. It turns out that because when you start to build the brain again, the different parts of it interact with each other. So in order to make a copy, you have to do it very, very quickly. Because if you don't do it quickly, the interaction will disturb everything. You calculate how quickly you have to make this, you find that the energy you have to put there because of the uncertainty between energy and time that says if you want to do something very quickly, you must put a given amount of energy. The energy will put there will necessarily make it boil. It could not survive. Mm-hmm. So I think that one can prove that about some complexity, there is no way to make a copy. Now, this is extremely important because that means that the whole idea of probabilities cannot apply to my brain. Nobody can come to me and tell me, look, we'll continue the experiment many times again to show me that I don't have the freedom, like I did to the electron. The electron, I told him, look, I can repeat this experiment many times and show you that you could not choose all the time to go to the right. Nobody can come to me. I have now the possibility of making one choice or another choice. And I decide to make the choice even though quantum mechanics may tell me the probability to make this choice is very small. But the probability does not apply because nobody could repeat the same experiment again and again. So nobody can stop me from choosing the small probability because there is probability does not have a meaning for a complex system that cannot be copied. Okay?
Okay.
This is extremely important.
So this is actually your statement. You say we apply the laws of probability to ensembles. For example, particles. You take 100,000 zillions of particles, identical, all of them electrons. And you show that when they go through what you call Stern-Gerlach magnet, it has a freedom to go either to the right or to the left. So you do it many, many times, and you are satisfied that in precisely 50% of the cases it went to the right, and then precisely in 50% of the cases it went to the left. So this we all know, and this is why quantum mechanics applies the laws of probability. This is the Born rule. Now what you're saying is something surprising. You say you can't apply the laws of probability to the human brain. Why not? You can apply the laws of probability to chairs, to tables, even to cats. Here is what you say which is new, and I must confess that it's very profound. You say that actually the laws of physics, not technology, the laws of physics, put a limit to our capability of making ensembles. I can make an ensemble of chairs, no problem, even a very complicated chair. I can make an ensemble of a pencil, of a book. This is what we do, and they are all identical. Take a real human brain at its present stage. These thoughts, these memories memories of the past, character traits and so on, all of them in your neurons. And now you want to make an ensemble of many Yakirs. Here is one Yakir, another Yakir, and make a probability law on all of them. It turns out actually what you say, and I think that you're correct. You can't do that. You can't do that because if you want to reproduce each neuron exactly as it is, and the same synapse, the amount of information that you need at a very short time is such that the uncertainty principle will ruin it for you. There is also another calculation of yours. You showed that the energy needed for that. We know that complexity and energy go together. If you produce a lot of information, a lot of complexity, you need a lot of energy. You will have to put so much energy in one place that it will create a black hole. So this is not a problem of technology. And I think that you are absolutely correct. This is one of the extremes of nature. You can't go faster than light. You can't have something smaller than a quantum. You can't replicate a human brain. So the laws of probability do not apply to it. And here is why we need a new theory of mind.
So let me conclude by saying that I believe that there is another revolution that is due, which has to do with complexity, that evolution, once we understand it, will give us a new way to think about us as human being a physical system, but a complex physical system that the laws of physics today, which are based on experiments on simple system, doesn't apply.
So this is what your revolution says. You say the previous revolutions went to extremes of nature. The fastest in relativity theory, no faster than light. The smallest in quantum mechanics, largest masses, black holes, and so on. These are the extremes of nature. And the physicist is a kind of an extreme sportsman who goes to the extremes. And then you actually say you neglected another extreme, and this is this extreme. It's not just complex, but I can show by some constants of nature, say the uncertainty principle, even perhaps speed of light or something like that, that you cannot replicate a human brain, a real human brain. So while the Born rule applies to electrons because you can take zillions of identical electrons and show that you can never know whether it will go to the right or to the left. So you make a statistics. What you are saying is that you can make a statistics on a brain because in order to make statistical laws, you need an ensemble. You will never have an ensemble of living brains because physics, the universe, actually gives a limit to that. So I understand this revolution. But still, here is what keeps bothering me. When Newton ruled in physics, then we felt in a straitjacket. How come that I am a slave of my past? If you believe in determinism, then people will say in psychology and so on, you're a slave of the past. Whatever happened to you in childhood, education, and so on, you're not free according to the laws of nature. Spinoza once said, if the falling rock could think, it would think that it is willing to fall. While it is the laws of nature that make the rock fall, and I think that I'm just doing this out of my free will, and the classical physics may say that there were previous reasons for that. Now you come and you purport to liberate me from the shackles of the past, but what are you giving me instead? You put me now in the straitjacket of being confined, not only by the past and by the future, and you say that you can restore free will by saying that I am not only being determined by my past, which I know and I remember and I can do something about it, but in somehow my choice at present is affected by things about which I don't know in my own future. Am I the only one who feels that you put me in it?
No, but the idea is that you're still playing a role about the future. Not that the future is only, it's a very strange idea. The idea is the following. You, as a present, try to make a decision about the future, right? And when you make that decision, usually you play a game in your brain. The game is you anticipate what will happen, how it will affect everything, and the kind of emotion that you get out of this game lets you choose between one possibility or another possibility. Now imagine that instead of just playing this game in your mind, actually you are able in some way to go in time, actually experience that things, see what all this development happened, and then come back to the present and say, do I like what happened there or not? So in that sense, you are free to decide what future to make. But nevertheless, the future comes back and affects the way that you make this decision. That is the kind of feeling I have.
But this is trivial.
Huh?
This is trivial. What you now describe, there is nothing revolutionary in that. Let's think about...
No, but instead of saying that I played this game in my brain, I'm saying that actually it happens in nature. In nature, what happens is that you are free to affect the future. But once you affected the future, it is there, and it can come back to you now and help you to see whether that future is the right one or not.
Are we now talking about classical physics or quantum mechanics?
No, we're talking about new physics that has both classical and quantum meanings.
So let me put it...
I'm just saying that quantum mechanics let us think about time in a new way that in classical physics could say could never happen. In classical physics, it could never happen that something that you do in the future can come back to the present and affect it, because that will mean that you can't have free will. That's called the causality principle, which is extremely important in physics. If you say that I can find in the present some result that is due to something that I'm going to do in the future, right? That immediately means that you don't have free will. Why? Because you find now that in the future you were supposed to do something. You found it. Then you can change your mind and say, I don't do it in the future. Then there is a problem, because you can't explain why it was there. That's why in classical physics it could never happen that what you do in the future can go back and affect the present. Okay?
But here,
in classical physics.
let me put the question this way. Okay,
Yeah.
My name is Raskolnikov. There is an old woman who gives me a lot of trouble. I owe her money. And I think, how about taking an axe and murdering that old woman? Nobody would know. So I'm still, just as you said, I'm still pondering whether I should kill the old woman or not. And you are now Dostoevsky. And you say, I found in the ABL rule, I found that a particle, you have to tie the two things together, Yakir. You said, many years ago, I found that a particle between two measurements is affected by both the past and the future. Now you, Raskolnikov, there is something in your future. Einstein said that the event, whether you murdered the old woman or you did not murder her, is just there like the present, which I feel, it's a straitjacket. Raskolnikov, does he has a choice? Does he have free will when he thinks about the moral question or not? And now you say that by quantum mechanics, by your work in quantum mechanics, by the fact that you cannot apply the laws of statistics on a brain, on any human brain, you can tell Raskolnikov that he has some freedom of choice, because he's running the scenarios of what he is going to do later, whether he will be caught by the police or not. This is the whole story. What is unique about your approach when you apply it to such a case?
So I'm saying the following. In classical physics, we saw that the time is very simple. There was a past that is not there anymore. There is a present where I have to make a decision, and there is a future that's going to be affected by my decision if I had some freedom, right? Now, I found out in quantum mechanics, at least for an electron, that its behavior in the present depends not only on what experiment I've done on it in the past, but also what experiment I will do with in the future. And I can show that that is true, and it's consistent because there are uncertainty relations. Otherwise, it would be inconsistent. Mm-hmm. So what happens in quantum mechanics, because there are uncertainties, then there is a possibility for a given past to make a different choice in the future. That's a new freedom that wasn't there in classical physics. Mm-hmm. So I first of all have the freedom to select in the future out of a number of possibilities, part of them. That selects not only all the electrons, but only part of them. So there is a possibility in quantum physics, contrary to classical physics, to define a new kind of ensemble. These are all the electrons that started in the same state in the past, and the part of them that ended up in the same state in the future, that's a small part. I can call this a new kind of ensemble, pre- and post-selected ensemble. And from this part, I ask what are the properties in the present. And lo and behold, when I think about only this part, I find beautiful new experiments that are now done all over the laboratories, where you do experiments that don't destroy both information, which are called weak measurements, and they found beautiful new features of quantum mechanics that nobody thought about. So, and it's full of experiments now done everywhere.
So